Okay, in this problem, you're given the limit as h goes to 0 of this quantity here. And you'll notice that if you directly plug in h equals 0 here, you'd get the square root of 1 minus 1, you'd get 0 on top, and of course you get 0 on the bottom. So you'd want to maybe algebraically rewrite this. And I'm not saying that you couldn't algebraically rewrite this, but here's a much nicer way of doing it. He used h instead of x for a reason. It's supposed to jog your memory of the definition of a derivative. Remember that if you have a function f of x, then f prime at a point a is by definition the limit as h goes to 0, so it looks the same so far, of f of a plus h minus f of a divided by h. So a lot of these things look real similar. The limit out front looks the same. The fact that I'm subtracting something looks the same, and the h on the bottom looks the same. So really the question I have to ask is, this would be exactly the definition of the derivative at a certain point a if I can think of a function f such that, and a value for that function a such that f of a plus h is equal to this first thing, the square root of 1 plus h. Okay, so is there any a in function f for which f of a plus h is the same as the square root of 1 plus h? Another question we'd have to ask is there any way I can pick the same f and the same a so that f of a would equal 1? And hopefully with a little bit of thought you'd realize that if I looked at the function f of x equal to the square root of x and I let a equal 1, then certainly f of a is equal to the square root of 1, which is 1, and f of a plus h would equal, well, if a is 1, then this is the square root of 1 plus h. And so that would give me exactly this expression. So for the value f of x equal to the square root of x, this is by definition, this limit is by definition the derivative at 1 where f is the square root of x. So what is the derivative of the square root of x? Well, it's 1 half x to the negative 1 half, right? Or 1 over, if you like, 2 times the square root of x. I think it simplifies down to that. So that's the derivative, that's what f prime of x would equal if f is the square root of x. So what is f prime of 1? Well, it's just 1 over 2 times the square root of 1. It's just a half. So that's one way of computing the answer, and it's the way you probably were expected to do it. So now we're asked to approximate the square root of 1.01. So what you'll notice is that if we look at the graph of the square root function, right, what does it look like? There's the graph of what I was calling f before. And we're asked to compute not f of 1, which would be easy, right? The square root of 1 is just 1. But we're asked something ever so slightly to the right of it, 1.01. So the idea is to use the best linear approximation, or the linearization, or the tangent line, whatever you want to call it. They all mean the same thing. I'll call that line L. Remember, it passes through the point 1, 1, right? The square root of 1 is 1. And how do I know to look at the line at that point? Well, because it's very close, I could have just guessed. Or, I mean, they did just ask me to compute the derivative at 1, which is what I would have to do to find the slope of this line anyway. So you could have kind of just, if you had done this, the part A correctly using this technique, you would have realized, I better compute the linearization at 1. That's what he asked me about. So if we compute this linearization at 1, right, it's given by the formula, the line L is given by y minus the y coordinate is 1 over x minus the x coordinate is 1 is equal to the slope at that point. Well, that slope is what we calculated in part A. It was just a half. So that y, if you solve for y in terms of x, it looks like a half x minus a half, just multiplied the bottom through, and then you add 1. Or in other words, y is equal to 1 half x plus 1 half. So this is the best linear approximation at this point. right? So if we plug in x equal to 1.01, then what would we get? Because that's what this is, right? The square root of 1.01 is just f of 1.01, because f is the square root function. And that's approximately equal to the value that its best linear approximation would equal at that point. Again, this is a horrible approximation over here if we go very far away from the point 1, but we're very close to the point 1, because we're just 1.01. So if you plug in 1.01 here, you would have gotten 1.01 over 2 plus a half, which I don't know, if you want, that's 2.01 over 2. So I just plugged in 1.01 here for x. That's it, 2.01 divided by 2, which I guess is 1.005, I think. So that should have been the answer, I believe.